The most important idea when multiplying fractions is to multiply straight across. That is, we multiply numerators times numerators and denominators times denominators. When we multiply 2/3 times 4/5, we're going to multiply 2 times 4 for the numerator of the answer and 3 times 5 to get the denominator of the answer. So it goes like this. This is just equal to 2 times 4, 8, 3 times 5, 15. So 8/15 is our answer. Now, there are a number of words that lead to the idea of multiplication. You know that times, we use the word times, 2/3 times 4/5 leads to this operation. But another word that's really important in this multiplication idea is the word of. 2/3 of 4/5 leads us to this operation. Let's look at another one. 1/2 times 1/2. Now remember again, it's numerators times numerators, denominators times denominators, so we multiply straight across. 1 times 1, 1 for the numerator of the answer. 2 times 2, 4 for the denominator of the answer. So 1/2 times 1/2 is 1/4. And we can think of this as 1/2 of a half. And we can even illustrate the idea of half of a half. You know, if we kind of look at this circle, well, half of the circle would be this shaded region. And then if we think about half of this half, you see, let's take half of this half. See, we would divide it maybe roughly right in here, and then we would have this portion. Well, half of that half is 1/4 of the entire circle. So no wonder we get 1/4 as the result. Here's another one, 2/3 times 5/6. Our idea is to multiply straight across, so we're multiplying 2 times 5 for the numerator, 3 times 6 for the denominator. Now, to illustrate this more fully, I'm going to show this. It's 2 times 5 to get the numerator of the answer, and it's 3 times 6 to get the denominator of the answer. So that's what we're doing, and when we multiply, we get 10 over 18. But we're not finished here because we can simplify this fraction a bit. And we simplify by reducing the fraction, and reducing means to identify a factor which is in both numerator and denominator and eliminate it. You see, we think of 10 as 2 times 5. We think of 18 as 2 times 9. And we eliminate those 2's, and we find that the reduced answer is 5/9. Now, there's a better way to arrive at this reduced answer rather than to go through this 10/18. And we may be able to see it back here. In fact, we can kind of see it right here, where we have a 2 in the numerator and we have in 6 a factor of 2. You see, so we could have worked it like this. We could have, from the beginning, we could have said, well, let's see. This is 2/3 times 5/6. And if I kind of stretch it out a little bit and use prime factors, you see, for all of these numerators and denominators, then in the numerator I would have just the 2 times 5, because those are prime numbers. And then I would have 3 times, well, 6 is 2 times 3. You see, think of it like this. And now we can see these two factors in both numerator and denominator, which can be taken out. Now, when we take them out, what we're really doing is taking out 2 over 2, which is a form of 1, you see. And so we're allowed to eliminate those like factors in numerator and denominator. Now, when like factors are eliminated like this, it's important to realize that there is an understood 1 factor left in their position. That is, 2 into 2 goes 1. That's how we say it. 2 into 2 goes 1. So what's happening really in the numerator is 1 times 5, 5. And in the denominator, we have 3 times 1 times 3, you see, which gives us the 9. It's important to know that the 1's are there because if everything happens to cancel, you see, in a numerator or denominator, we need to realize that there is no vacancy there. There's really a 1 factor that remains. Take a look at this one. We have 4/15 times 5 over 28. And when we multiply, we are multiplying straight across, so it's 4 times 5 for the numerator, 15 times 28 for the denominator. Now, if we multiply the numbers out, 4 times 5 would be 20, and 15 times 28 would be a pretty big number. And then we would have to go about the business of reducing, and it's much easier to take care of that reduction business early in the problem rather than multiplying out to get all those big numbers. So to do that, we might look at prime factors in the numerator and denominator. 4 can be written as 2 times 2. So in the numerator, we have 2 times 2 times 5. In the denominator, 15 is 3 times 5. 28 is, well, let's see, it's 4 times 7, but 4 is 2 times 2. So this is 2 times 2 times 7. And now we look at like factors in numerators and denominators, and we say 2 into 2 goes 1, 2 into 2 goes 1. You see, I've eliminated those like factors in numerator and denominator. I see a couple of other 2's here that can go out. I take them out in the same way. I see a 5 here and a 5 here. 5 and a 5, 1. 5 and a 5, 1. So what's left is, let's see, in the numerator I have 1 times 1 times 1. Well, that's a 1 for the numerator, and 3 times 1 times 1 times 1 times 7. It's just 3 times 7, you see, to give 21. So 1 over 21 is the answer. Now, it's not always the case that we have to use this idea of a prime factorization. It's kind of a handy way to do the situation to accomplish the reduction, but we can accomplish it in another way. Let's come back all the way to this point in the problem. A lot of times, and most of the time, I think in the future, we're going to find that here's what we look for in the multiplication process. We're looking for like factors in numerator and denominator, and we won't always write them out. That is, we won't always go through a factorization process. We'll simply observe that 5 is a factor in 15, and 5 is a factor here. So we can take out the 5 in 15, and we can take out this 5 factor, and we do it like this. 5 into 5 goes 1 time, 5 into 15 goes 3. You see, we put the leftover factor right here. So we've eliminated the 5 factor in 15, and it leaves the 3 factor. We end up with the same result that we did before, of course, but it's just a different strategy, and it's a little bit faster. Oh, notice also I'm using the dot here to indicate multiplication. The time sign indicates multiplication like this, and this is another kind of time sign, and I just want to point it out here to you. But let's see, let's continue with the reduction business. The 4 and the 28 can cancel because there is a 4 factor in 28. And if we recognize that 28 can be thought of as 4 times 7, then here's what we do. We just say 4 into 4 goes 1, 4 into 28 goes 7. And now we go straight across, 1 times 1, 1, 3 times 7, 21, to get the answer that we expected. Here we're multiplying a common fraction times a whole number. And in this kind of circumstance, we think of the whole number as though it were a fraction. And we can do that rather easily. Every whole number can be regarded as a number over 1. That is, we can rewrite this as 2/3 times 5 over 1. After all, 5 divided by 1 is 5. And writing it in this form allows us to multiply straight across rather easily. We don't get confused about what numbers are in numerators and what numbers are in denominators. So we have 2 times 5, 10, and 3 times 1, 3. Now, 10/3 is an improper fraction, and we would want to write this as a mixed number. So we need to perform the division that is indicated here. This is 10 divided by 3. Now, sometimes we'll be able to see right through that division, and other times we won't be able to, and we'll have to perform the division somewhere off to the side. I think we can kind of see it here. 3 goes into 10 3 times with 1 left over. So it's 3 1/3 for 10/3. Here's another one. When we're multiplying a couple of mixed numbers, it's important to change them into improper fractions. So let's do that here. For 3 1/2, the speedy way to change this is to think of 2 times 3 is 6, plus 1 is 7. So this is 7 over 2, 7/2, times 3 times 2, 6. 6 plus 2, 8. So this is 8/3. Now we can multiply straight across. Let's look, though, for cancellation opportunities. Now, we can cancel factors in any numerator with factors in any denominator. That is, we can cancel up and down, or we can cancel diagonally. You see, but we certainly can't cancel like a like factor from one denominator to another. We certainly can't do that. Okay, so we're looking for opportunities. I'm looking around here. Oh, I see one. The 2 here with the 2 factor in 8. 2 into 2 goes 1. 2 into 8 goes 4. And now I don't see any other opportunities to cancel, so I multiply straight across. 7 times 4, 28. 1 times 3, 3. 28 over 3. Now, this improper fraction changes to a mixed number, but I can't see through this one as easily as I could the one before. So I'm going to show the division here. And when you show the division in a situation like this, that division is part of the demonstration of the problem. And it's important to show that as though you're kind of proud of it. You don't want to just scribble it in a margin somewhere and scratch it out or something like that. You want to show it and show it in a way where someone looking at the problem later could observe that division part of the problem. All right, it's 28 divided by 3, so it's 3 into 28. Let's see, 3 goes into 28 9 times. 9 times 3, 27. We subtract and get 1 as the remainder. So this is 9, and then we have the remainder over the divisor, so it's 9 1/3. So this becomes 9 1/3. By the way, I want to point out one more thing to you. You notice that when I'm working through the problems here, sometimes I work up and down. Like here, to change 3 1/2 into 7/2, I went up and down. And here for 2 2/3, I went down to make this, or to cause it to become 8/3. And then I ended up going across. And I go across because it's real easy to see numerators times numerators, denominators times denominators. But really, it doesn't make any difference. You could work the whole problem underneath. We could say 7 times 4, 28, and put it here. And then 1 times 3, 3, and put it under the 28, and it would be perfectly all right. So it's really whatever strategy works well for you. It's whatever your preference is. I could have changed this into improper fraction form by going out to the right, you see, in this step if I had wanted to. So I can work in either direction and it's okay. Here's another situation involving mixed numbers, and notice that the numbers are a little bit bigger this time, but the idea is exactly the same. We need to change the mixed numbers into improper fractions and then multiply straight across. Well, to change the mixed numbers into improper fractions, 7 times 3 is 21 and 1, 22 over 7. 22 over 7. Notice I'm leaving a little more room here between this part of the problem and this part, and I'm anticipating that I'll need a little space in here to show the leftover factors if I can identify some cancellation opportunities. So you might keep that in mind as you lay out your problems. Let's see, 2 1/8 becomes 8 times 2, 16, and 1, 17 over 8. So 17 over 8. We're multiplying these rascals, and now we look for the cancellations. I see one here with the 8 and the 22 because they're both even. So 2 into 8 goes 4. 2 into 22 goes 11. So now I multiply straight across. Gee, I can't multiply 11 times 17 in my head, so I'm going to come out to the side and show that. I'm going to write 17 times 11, and this is part of the demonstration of this problem. So be proud of this, and don't scribble it or anything like that. Just make it part of this problem. So let's see, 1 times 7, 7. 1 times 1, 1. 1 times 7, 7. 1 times 1, 1. 7, and vacancy is 7. 1 and 7 is 8. And 1. So 187. So I slide back over here. And again, I can work out to the right if I want to, but gee, I'm a little jammed with space right here. So 11 times 17 I found to be 187, and I'll just write it right down here. And now 7 times 4, 28. Now I have an improper fraction, and I can't see through this either. I can't do this in my head. So I'm going to go ahead and show the division of 187 by 28. So it's 28 into 187. Let's see, it looks like it goes about, about 6 times. Now I'm thinking that I'm thinking of using a 3 here because 28, if I go to the nearest 10, you see, I would be thinking of 3. You see, I'm using that single digit idea. 3 into 18 goes 6. That's what I'm thinking. So I'm going to use 6 here, and let's see if that works out. 6 times 8 is 48. I'm carrying 4. 6 times 2, 12, and 4, 16. And now I subtract. Well, gee, 7 minus 8, can't take 8 from 7, so I need to borrow from the 8. It becomes a 7, and the one that I borrow makes this 17. 17 minus 8 is 9. 7 minus 6 is 1, so 19 is the remainder. I have 6 for the whole numbered part, 19 is the remainder. I put the remainder over the divisor, so I have 19 over 28. So let me slide that answer over here. It's 6 and 19 over 28 for the final answer. Here's a word problem which leads to multiplication in its solution. An electrician earns $206 for each day worked. What are the electrician's earnings for working 4.5 days? Now, the multiplication comes in because, well, we can look at it a couple of different ways. We can say, well, gee, this person makes $206 every day. And we're talking about 4.5 days. So day 1, $206. Day 2, another $206. We could add, you see. Day 3, another $206. We could add. And day 4, another $206. And then a half a day is half of $206. You see, so we would be adding 206 4 times. You see, 4.5 times actually, but it's 4.5 times 206 is a better way to look at it. So we just multiply 206 times 4.5. Now, when we set it up, it's 206 times 4.5. That's what we're doing. But in order to go through the multiplication process, we think of the whole numbered part as the whole number over 1. And then the mixed number as an improper fraction. 2 times 4, 8, and 1, 9. So this is 9 halves, 9 over 2. Now I have a cancellation here. 2 into 2 goes 1. 2 into 206, well, I know it goes evenly, but it's hard to see because it's a pretty big number. So I'm going to go out to the side and do the division. I'm going to say, how many times does 2 go into 206? It's not trivial here. Now maybe we can see through it okay, but maybe not. Maybe we want to be really sure about this. So we go out to the side and we say, okay, I'm dividing 2 into 206. Let's see, 2 into 2 goes 1. 1 times 2 is 2. Subtract, I get 0. Bring down the next digit. Oh, 2 doesn't go into 0. I need a placeholder here. You see, or I can say 0 times 2 is 0. And then bring down the 6. 2 into 6 goes 3. 3 times 2 is 6. No remainder here. It goes evenly as we expected. So 103. So 2 into 206 goes 103. We might have been able to see it ourselves like this. We might have been able to say 2 into 2 goes 1. 2 doesn't go into 0. You see 2 into 0 goes 0. And then 2 into 6 goes 3. That would be fine as well. All right, so we have 103 times 9. And once again, 9 times 103, not a trivial situation. So we might come over to the side. 103 times 9. 9 times 3 is 27. I'm carrying 2. 9 times 0 is 0, plus the 2 that we carried is 2. And then 9 times 1, 9. So 927 is our answer. Now notice that when we write the answer, it's 927, and technically we have 1 times 1 is 1 for the denominator, but 927 over 1 is 927. So this is $927 is the electrician's earnings for the 4.5 days of work.